Welcome everyone to 7.4a. We're going to do the first half of the section and more realistically the first third of the section. And this is mostly going to be very similar to what we've done in 7.3, which is good. Your test is coming up. You're going to have a test at the end of chapter 7, and 7.4 is the last section in chapter 7. So the more and more we can get concepts connected to each other and do some review and weave all the topics together, the essentially better you're going to be doing on your exam. So tomorrow is going to be 7.4b, and that's going to involve some odds and ends, but it should be familiar, should be odds and ends of things you've seen before, but that we're now tying into trigonometry. Okay, so here we go. So if you remember to have a pen with ink in it, when we talked about the unit circle, right? The unit circle was a circle of radius 1, and I made a big deal about how I almost never like using the unit circle unless we're talking about quadrantal angles. So it has a radius of 1, which means this is the point 1, 0, right? This is the point 0, -1, and there's a whole bunch of points on this unit circle, literally infinitely many points on this circle. Okay, and what we did is we said, well, we can use this to find what the cosine of 0 degrees is, or the cosine of -90 degrees is, because cosine of an angle is equal to its x component at that point on the unit circle. So specifically, sine of an angle was its y coordinate on the unit circle, and cosine of an angle was its x coordinate on the unit circle. So cosine of -90 degrees would be 0, the x component. Sine of -90 degrees would be -1, the y component. So now we're just going to expand this concept. Okay, and remember where this comes from. If we're looking on a circle, let's draw ourselves another circle over here, maybe a little bit bigger. If we're looking on a circle, and if this is the unit circle, right, this is the point x comma y. Well, the x component is our adjacent side of our angle. The y component is our opposite side, and then the radius is 1. So that's where this comes from, and that's why the radius is always positive. Even though x will be negative over here and y will be negative down here, the radius is always 1, or the hypotenuse is always 1, because the radius is always 1. Anyway, so we can extend this, right? If sine is y over 1, or just y, cosine is x over 1, just x, well, tangent is opposite over hypotenuse, that's y over x. And while we're at it, let's do the other three. Cosecant is a reciprocal function, that's 1 over y. Secant is a reciprocal function, that's 1 over x. And cotangent is a reciprocal function of tangent, so it's x over y. And again, just like everything else in this section, once you find a couple trig function values, the other ones are so easy and so quick, as long as you remember what cosecant, secant, and cotangent are talking about. Okay, specifically in this section, you're going to get some problems that say find all 6 values. And really, that's not going to take much longer than finding one. The worst part about the problems where they tell you to find all 6, you just have to write them all down. It's not hard to find them. Well, it's not hard to find after the first. But it is a little tedious to write a lot of things down. So let's get to it with some examples. All right, let's do example 1. A little bit of foreshadowing, but find the 6 trig function values of theta for the following thetas. And again, this is just an abbreviation for function, FCT, function. And the first one is some point on the unit circle. So imagine, if you will, there's a little unit circle going on here. Imagine that's a circle, please. And this point over here is the point -√3 over 2, comma, 1/2. So a very good point can be made here is that we're supposed to find what the sine of theta is. We're supposed to find what the cosine of theta is. We're supposed to find, etc. You get the idea. It doesn't matter what theta is. We don't need to find theta at all. All we need is the trig function values of theta. And that's going to be kind of a difficult concept in this whole semester, is when do we actually need theta, and when do we just need to know trig functions of theta? So here, just need to find the trig function values. So we make a little list. Say you have no clue how to do this problem. What if you just don't know? Then you at least write this down. I don't know how to find these things, but I know what you're asking me to find, Jason. So just do that. And that's the best way to start these problems, is saying, okay, this is what's getting filled in. I might not know how to fill it in, but here we go. Cosine is x and sine is y is what we're going to use here. So sine of theta is the y coordinate. That's 1/2. Cosine theta is the x coordinate. It's -√3/2. And then you got to be a little careful here with tangent. You're going to test your knowledge of complex fractions, right? Tangent's y over x. Y is 1/2. Divided by x is -√3/2. And we have a couple ways of dealing with these complex fractions. One way to deal with these complex fractions is to say, okay, well, that's just 1/2 divided by -√3/2. And that's perfectly great. It's a perfectly decent way to solve it. I really like the second way. The second way of evaluating these is to multiply the top and the bottom of the big fraction by the least common denominator of the little fractions. So in this case, we multiply these top fraction by 2 and the bottom fraction by 2. The fractions go away. So 1/2 times 2 is just 1. Half of 2 is 1. And -√3/2 times 2, the 2's cancel again, you get -√3. And either way, that's what tangent is. -1/√3. And again, I'm not going to make you rationalize the denominator, but if you did, it would be √3/3 with a negative in front. And now we've already done all the hard work. Now we just flip everything to get the reciprocal function values. Cosecant is the reciprocal of sine, it's just 2. Secant is the reciprocal of cosine, that's -2/√3. Cotangent is the reciprocal of tangent, it's -√3. And here we are. So let's apply that information and do it again. We're going to do this so many times that you're just not going to be able to mess it up. All right. And how many times that is? It's one more time. Okay. So part B is now, let's look at 270 degrees. This is the angle that goes all the way down here. So again, it's the point 0, -1. If you're looking at a unit circle, it'd be around here. But this is the angle. But again, we don't need the angle. We don't even need the picture here. All we need is the x and y coordinates. Sine is y, cosine's x. So we sigh a little bit, maybe shake our heads a little bit, say, why the heck did Jason assign so many of these problems? Because we have to write down so much of the same stuff, but we're not even doing that much math. You might say that to yourself. Sometimes just beating something to death is the best way to get it into your head. So sine is the y coordinate, -1. Cosine is the x coordinate, 0. Tangent is y over x. -1 divided by 0. What is that? Undefined. So tangent is undefined. And we usually, oh crap, I don't have enough room to write. We usually don't write equals undefined. We just say tangent is undefined. Something like that. The equal sign doesn't really make sense. Equal to a word or a concept. Anyway, cosecant is the reciprocal of -1. 1 divided by -1 is still -1. Secant is the reciprocal of 0. 1 divided by 0, also undefined. So we're coming into some messy business here. And cotangent, reciprocal of undefined. Let's not use that version. To find cotangent, cotangent's x divided by y. So 0 divided by -1. Which is 0. A lot of people can get confused between 0 divided by -1 and -1 divided by 0. If 0 is on the top of a fraction, that's okay. You can use your calculator to verify this. 0 is on the top of the fraction, it's okay. It just means it's equal to 0. If 0 is in the denominator, that is not okay, and that means undefined. So be very careful about these two situations. They are not the same. If you're ever in doubt, check your answer on your calculator, okay? So there we go. This angle was a little less well behaved. We got some undefineds going on here. And again, I mentioned earlier that if you're looking at trig function values of quadrantal angles, angles that end on one of the axes, angles that are not in a single quadrant, that's where quadrantal comes from. There's really only a couple options: 0, -1, +1, and now there's undefined, because now we have reciprocals. Okay, so watch out for that. All right. So we've got one more example with 2 parts. And that's all we're doing today. A nice chill day to make up for yesterday. Yesterday was long. Tomorrow might be kind of long too, but not as long as yesterday. The 7.3 lecture was pretty long. So let's go to example 2. And let's use this for some interesting stuff. Again, you might think, haven't we already done this? And if you think that, that's great, because that means you're connecting concepts and extending concepts in your head over just what we're talking about. So if this looks familiar to you, that's great. And if it doesn't, well, that's why we're doing it in 7.4. Example 2 is find exactly. Nope. Find, it's exactly the same as example 1, really, just phrased differently. Find the 6 trig function values of the following. Part A is -5 pi over 6. If you remember back to the start of, this class, one of the things that I asked you to do is graph angles. And that may have felt a little silly saying graphing angles. What's the point? Well, we're doing it all the time now. It is extremely important that you can graph these angles. Graph these angles correctly. Okay? So, what we're going to do here, draw our coordinate plane, -5 pi over 6. Remember, that is close to 6 pi over 6. So it's close to negative pi. Negative pi is negative 180 degrees. So we're going down 180 degrees. But it's not actually negative pi. It's almost negative pi, but we're missing a little slice of that pi. Okay? So really, we're something like this. This is -5 pi over 6. And just like in 7.3, the important thing is not the -5 pi over 6. The only important thing here is the reference angle. And the reference angle is how far away it is from the x-axis. We are pi over 6 away. It's always going to be a positive number, right? If we put an extra pi over 6, that's a negative on here, then we'd reach the x-axis with -pi. And then we refer to the special triangles that I will always give you on quizzes and exams. That looks something like this. All right, and we use this special triangle to get our trig function values. So, what do we got here? Well, if this is pi over 6, down here is the opposite side. Yeah, it's a 30, 60, 90 triangle. We're using radians right now, but they're equivalent. And again, as a reminder, by the end of this class, you're going to know radians like the back of your hand. Pretty sure. At this point, if you're worried about points, feel free to always just convert. If you want to convert everything to degrees, be my guest. I'm going to be using a variety of both just to try to get you more comfortable with radians. But yeah, feel free to use both whenever. I won't be offended or anything. I know there are some trig teachers out there that if you use degrees, they're going to jump on the desk and start throwing things, and maybe a slight exaggeration. Anyway, let's get back to it. So this side is the side that's opposite pi over 6. The side that's opposite pi over 6 is 1. And again, we don't have to use this exact triangle. We could use a scaling of this triangle. We could double all the values. We could quintuple all the values. We could divide all the values by 2. The size of this triangle doesn't matter, only its relative dimensions. Because when we're doing trig, we're only caring about ratios. Okay? So, if this is 1, this is root 3, and this is 2, and the only remaining question before we start pumping out some trig function values is what values get negatives. So up here, this is the x component. Well, we're going to the left. So the x component's negative. Over here is the y component. Well, we're going down. So the y component's -2. Hypotenuse is a radius. Always positive. It's a length. Always positive. But these two things can be positive or negative. Okay, so here we go. We need to find the six trig function values, so let's just start writing them down. Sine of negative 5 pi over 6. Ugh, a lot of writing. Cosine of negative 5 pi over 6. Yep. Tangent of negative 5 pi over 6. Just spam them all down. All right. I'm not going to have room in a second column. Cosecant, negative 5 pi over 6. Secant of negative 5 pi over 6. Fun fact, there is a quicker way to write this all down. If you're really lazy, and I'd be doing this if I weren't recording a lecture right now, if I were really doing this, I would just say, hey, let's call this theta. And then we look at sine theta, cosine theta, tangent theta. You can define this to be a variable if you want, and then they're interchangeable. And theta is much quicker to write than negative 5 pi over 6. So feel free to do that if you want. I will not only accept that, I will be inwardly pleased. Okay. Anyway, sine, opposite over hypotenuse. Negative 1 divided by 2. We have negative 1/2 for sine. And we just go through this. You've been doing SOHCAHTOA for a long time now. Like 3 weeks, at least. That's if you haven't seen it before. So you're probably good with SOHCAHTOA. Again, if you're not, here we go. It's very important. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, etc. So cosine is the adjacent side, negative root 3, divided by the hypotenuse, 2. Tangent is the opposite over the adjacent. So 2 negatives, they're going to cancel. We just have 1 over root 3. And now we are really sitting pretty because we found the 3 main trig function values. Now we just need the reciprocals. Just take the reciprocal. We reciprocalize this, not a word, don't use that. And we get negative 2. We reciprocalize this. We get negative 2 over root 3. Just flip it upside down. And this one becomes square root of 3 divided by 1. We don't need to write the 1. And there is our beauteous answer. All right, and that's really all there is to it. And again, this should fit with our understanding of all, well, I don't know, whatever way you want to remember this. Everything should be positive in the third quadrant, first quadrant. We're in the third quadrant here. This says that only tangent should be positive. So sine's negative, cosine's negative, tangent's positive. Good. Negative, negative, positive. Great. This says only tangent should be positive. And indeed, only tangent is positive. Good little way to check your answer. All right. You ready to finish the video? Let's do part B. Negative 7 pi over 4. And if you're really feeling like you want more trig right now, don't worry, I've got you covered. You can look at the past videos and watch them again to just fill your evening with trigonometry, or your morning, whenever you're watching this. All right, so we do this again, and we need to draw. Let's change this example. This is in the same quadrant. I don't want this garbage. Let's use negative 9 pi over 4. Okay. Wait, no, never mind. That's fine. That's not in the second quadrant at all. Let's use negative 7 pi over 4. Woo! Okay. All right. Not in the third quadrant. Let's go ahead and move on. So negative 7 pi over 4. 7 over 4. That's more than 1. So we have more than 1 pi going negative in the negative direction. And then once we go 4 pi over 4, we have 3 pi over 4. Again, 3 pi over 4, that's more than a half. So we go another 90 degrees. And we're only left with a pi over 4 after that. So this angle is actually kind of a Pac-Man angle, if you will. Goes all the way down and finally comes here where the angle is pi over 4. Oh my word, it's our lucky day. Everything in the first quadrant is always positive. We have fewer things to worry about here. So we just use our other special triangle. We have a pi over 4. The two sides are going to be the same. And the hypotenuse is going to be the square root of 2 of whatever your other ones are. So I like to call these 1, 1, and root 2, but you can make any scaling of this. So again, normally once you fill this in, you have to say, okay, what's negative? But we're in the first quadrant. First quadrant, x is positive, y is positive. Hypotenuse is always positive. Everything's positive. Great. Just like I'm positive you all will do well on your quiz this week and your exam next week. All right, so here we go. I say quiz this week, exam next week. The exam opens up next week, but it's not due for the week after that. You have a week to do all the quizzes, homeworks, and exam. Anyway, here we go. So this time I'm going to be lazy, okay? Let's call this theta. Save ourselves a little writing. So we're going to find what sine of theta is, what cosine of theta is, what tangent of theta is. You're going to get very good at writing all this stuff down, okay? Because you're going to get a lot of practice on those homework assignments. Sine, opposite over hypotenuse, 1 over root 2. Cosine, adjacent over hypotenuse, 1 over root 2. Tangent is opposite divided by adjacent, 1. And now we just flip that all upside down. And you may say, oh, but we were so happy, we were so positive. If we flip it upside down, we're going to be sad. But luckily for you, math doesn't work that way. If you're happy and you flip it upside down, you're still happy, still positive. So don't worry. Square root of 2 is the reciprocal here. Square root of 2 is the reciprocal here. And the reciprocal of 1 is just 1. And what a breeze. Very similar to the previous section, just with a few added twists. In the second part of this section, we're going to start talking about, let's see, odd and even functions. We're going to be talking about a very minor trig identity. We're going to do, again, another problem that's really similar to what we did in 7.3. So most people should, I would expect, have pretty good experiences with 7.4. And that's it for the day, okay? So another video lecture is going to be posted tomorrow. Your homework's already posted. Most of you should be able to do all the homework assignment today, probably. But we'll talk about more stuff in some, well, not all of it. There's a couple things in 7.4 that might trip you up that we'll talk about tomorrow. Anyway, let me know if you have any questions on anything that we talked about here, or send me an email, and have a good day.